Hello, everyone. It's a good afternoon and good evening, dear authors and invited guests. This is a technical session 8B, and myself, Richa from India. This session will be moderated by me on the behalf of the Global Knowledge Research Foundation. It's my great pleasure to welcome you to this sixth international conference on world smart trends in system security and sustainability. I hope you will enjoy the knowledgeable and interactive session through the day. And in this session, we have a six papers. We have a six presentations, and in six presentation, we will allocate a 12-minute for presentation and 3 minutes for question answer. So, and in this session, and there is a one more request to everyone: kindly please stay connected with us till the closing remark. So, in the end, we can take a one quick snapshot of making this virtual conference more memorable. And in this session, we have one chair of this session, and I would like to welcome Professor Nitesh Bhatt. He's a professor of Nirma University in Ahmedabad, India. Welcome to you, sir.
Thank you, Dr. Richa.
And now I would start with papers. I would like to call our first presenter to present her paper on Authentication Protocol for Intelligent Electronic Devices in an Edge IoT Environmental with Key Agreements. Paper presenter is Elena.
Welcome, Elena.
Hello, everyone. My presentation.
Before Elena, you start, I request all the participants, whenever somebody is present, we request please turn on your camera so that everyone can see you.
Okay.
Thank you.
Okay. I would like to present the new authentication protocol with edge computing. An important condition for the functioning of systems such mobile, vehicular, or flying ad hoc networks and cyber-physical system as a whole has recently become the real-time data processing and analysis. To ensure this aspect, edge computing have been invented and are being developed. The edge computing servers are located in physical and logical proximity to the resource-constrained intelligent electronic devices, IoT devices, in edge architecture, as shown on the slide. This architecture has the following advantages. Firstly, ES has significant computing resources, which allow not only pre-processed data for the transferring to a cloud, but make decisions as well, for instance, whether it should authenticate a device or not. Secondly, ES can perform functions of firewall, intrusion detection or prevention system, and data leak prevention system within local subnets of connected devices. Thirdly, it's combined with the 5G data transmission standard due to the use of short waves, which have poor throughput and as a result, a short propagation range. Lastly, computational load can be transferred from resource-constrained devices to the ES, and cryptographic outsourced protocols can be used. However, this also entails the need to adapt the interaction protocols to the new architecture. And one of the most important aspects is security in general and authentication in particular. There are 5 edge communication models between devices. First, interaction between ES and the cloud servers. It allows to transfer pre-processed data to a cloud where it's stored and processed along with data from other edge servers. Communications between edge servers is an important part of this architecture. ES receives data from different IoT devices and process it. Later, result can be transferred to another ES. Third model involves transforming data from IoT device to ES. Then the edge server either performs post-processing of the received data or transfer it to the cloud server. Next one, similar to the previous model and includes communication between IoT device and the cloud server through ES. But in this case, preprocessing isn't performed. The last interaction between IoT device with another IoT device through ES. Devices can share different data, for example, control commands, collected data, some state requests. And there are well-known authentication protocols which can be applied to first four models. But as for fifth, there is no algorithms for secure communications between IoT devices through ES with key agreement. I would like to propose my version of this authentication protocol for fifth model. In the developed protocol, device 1 is authenticated on device 2 through the server, or in another words, control device authenticate managed device. Before starting the protocol, these devices must be preloaded with an authentication key or access key, and the edge server receives from the trusted registration authority the signature value generated for unique data that identifies the edge server on the network. The protocol also uses random values of R and Q, asymmetric signature and encryption key, and various types of cryptographic algorithm as shown on the slide. On the first step, device 1 sends to the ES on public encryption key and secret signature key. Using received encryption key, ES generates ciphertext of masked by random value ES signature. Then device 1 decrypt value, and if signature verification is passed, received value will be saved as a key for secure communication with ES. Successful completion of this step means that the ES is authenticated in front of device 1. Further, device 1 forms this and sends to the ES ciphertext of access key using authentication encryption algorithm. If key was successfully decrypted with integrity check, ES sends to the managed device cryptogram of the ES signature, which is masked by new random value, and the device's one public signature key. Managed device decrypts value and verifies the ES signature. If correct, the authentication key is correct too, and the device saves device one public signature key and plain text as a key for secure communication with ES. As a result of key agreement, IoT devices have key for secure communication with ES, and ES has set of keys for all authenticated and managed devices. The resulted key shown on the slide, in the end of the slide. This slide shows a diagram of the use of generated keys for secure management of device 2. Control device forms the command and signs it. Then sends cryptogram of command and signature to the ES. And after the decryption, after the decryption, ES re-encrypts value using key of secure communication with managed device. If the digital signature of the encrypted command is correct, the received command is authentic and must be executed by the device. As you can see, developed protocol provides flexibility because it's possible to choose any specific algorithms and allow to select algorithms for the computing capabilities and the required cryptographic strength. Also, protocol ensure ES authenticity by checking the signature value for unique data. Protection against non-plain text attack is provided by masking the ES signature value by random values. As a result, the ciphertexts always have different values. And the last important security features is energy draining. The DOS protection is provided by additional verification of the values received from the control devices. In conclusion, it can be said that the developed protocol provides authentication in a little studied model of the device interaction in an edge computing architecture. It has many advantages and security features. Also, of course, it's allowed to build security IoT networks in a more efficient way. Thank you for your attention. Please feel free to ask any question.
The audience who is here in the session, if you want to ask some question. Okay, Elena, good presentation and
Thank you.
valuable contribution. I appreciate.
Yeah.
No, we have listened to your conclusion. Just a couple of questions from my side. What do you mean by edge IoT device? So we know about edge computing and we know about IoT. So what is edge IoT?
Edge IoT connected with the computing architecture. If in the network, if network include edge server and communication with edge server only performed in this network, the IoT devices started to be edge IoT device, I think.
Okay. Right. So any device which is connected to the edge server is known as edge IoT, right?
Yes. In the nowadays way of developing the edge communication, this conception is right.
Right. Throughout your security authentication, you were talking about public key cryptography. You were referring to public cryptography, right? Cryptography, public key.
Yes.
So are you? Does it include private key also?
There are many cryptographic protocols uses at this and this scheme, and as you can show on the slide, 1 minute.
So which algorithm? Which algorithm you are proposing or you have used?
Many type of algorithms are used on this protocol, and signature algorithm and asymmetric encryption algorithm, as you can show on the second and third step.
Right.
Symmetric encryption and symmetric authentication encryption, many types use at this protocol.
Very quickly, can you tell what is this key agreement?
Key agreement for this protocol, it's a result of the protocol also shown on this slide. Because of device ID and device 1 and device 2, as a result of protocol stored key 1 and key 2, as shown on the end slide, and they can use these keys to secure communicate with edge server.
Okay. So thank you, Miss Elena. It was a good paper and there was useful learning. All the best.
Thank you very much. Goodbye.
Bye. Now I request our next presenter, Mr. Prashant Vats, and he is going to talk about OFDA, a comprehensive and integrated approach for predicting estimated delivery time for online food delivery. Mr. Prashant. Prashant, are you here?
Sir, I think the presenter is absent. So Can we move forward to the next presentation?
Yeah, next one. And in the meantime, you can coordinate with him.
Yeah. Yes, definitely.
Is Miss Tumelo Presley here?
Yes, I'm here.
It's a Mr. I'm sorry. So here we have our next presentation. Its title is a multi-model biometric secured ATM, right? And it will be presented by Mr. Tumelo Presley. Yeah, Tumelo, welcome.
Thank you.
I requested you pronounce your name for collective benefits because all of us are coming from different countries, so that will be useful.
Oh yes. Can you see my screen?
Of course. Green T-shirt.
Yes,
Yeah.
so cool. Thank you. Greetings to everyone who is here.
Greetings. Yeah.
Yes, so I'm going to present my paper entitled A Multimodal Biometrics Secured ATM. I'm currently doing my master's with Tshwane University of Technology. And my co-authors is Professor Chunin Du and Dr. Moses Olaifa. Introduction. So whether you lose your card or forget it at home, or forgot your PIN, maybe you forget your mobile phone, or your card gets stolen and someone withdraws your money, losing money can be very much stressing. So it is very much crucial for banks to provide a secured and anytime accessible money in ATMs. So currently the authentication method that is used in ATMs is dependent on ATM cards and the memorized PIN. So these things can be forgotten, and the use of data that can be stolen must be avoided at all costs, as identity theft is on the rise due to the technology development, especially the IoT and social media. So it is important to improve security on ATMs. This is what this study is all about. It's about improving security on ATMs, prevent theft of cards and frauds, and create an independent and anytime access to finances, and guarantee and provide a guaranteed and reliable authentication.
Excuse me, Tumelo.
Yes.
Are you presenting any PPT?
Pardon?
Are you using any aid, some PowerPoint presentation? I can't see anything.
You're not. Oh, my apologies. I've been.
Please do that now. Please do that.
Oh. Do you see it now?
It's coming. It's coming. Yeah, it has come now. Maybe you can quickly summarize. No issue.
Okay, so yeah, my apologies on that. Let me just quickly run back. So yes, I just passed here to say that this is my title of the paper, and this is what I've been speaking about, that it's very stressful to lose your money due to identity theft and the use of ATM cards and the memorized PIN. So it is very crucial for banks to provide a secured and anytime accessible finances in ATMs. So they have to ensure that only the account owner can access the money. So in this paper, we adopt the biometrics features, which is the fingerprint and face, due to their accuracy and reliability. They were chosen when combined. So we did some literature review on some of the papers that were conducted before, which is M. Duta, who with his co-authors, they use fingerprint and the traditional PIN to improve security and replace the use of ATM. Similarly, S. Rajput and his co-authors discusses the same principle of fingerprint, but instead of the traditional PIN, an OTP PIN is used. So the other papers we reviewed were on the face recognition based systems, which both one of them was using the OTP PIN, and the other one was only the face recognition to authenticate users. And also, I also reviewed the cardless multimodal biometric solution, which uses fingerprint and face to improve security in ATMs, which some of them I found to be less accurate. So methodology. In this paper, we introducing the use of multimodal biometrics, which is a combination of fingerprint and face, with multiple fingers registered to improve accuracy. So, and multiple face images are trained. So the user will go to the bank and register their fingerprint and face. 2 fingers are captured and registered to allow for options when the user goes to do transactions on the ATMs. So the faces, the 3 faces will also be captured from different angles and trained on the system. The user gets registered and is now eligible to transact on the biometrics ATM. So the fingerprint scanner and the webcam will be embedded in the ATM. Here we use a Atmega 328P processing unit, which is the Arduino Uno IC. So, and on the ATM, there will be a Windows application installed based on C#. So the customer goes to the ATM and places their registered fingers on the scanner. If the fingerprint matches, then their face will be captured and compared with their registered face image. The user is then granted access when both the fingerprint and the face matches. So continuing on methodology. So in this study, we use an Adafruit optical fingerprint scanner on the system, which gets the fingerprint image and extract miniature from it to be able to differentiate the images using the 5 key steps listed on the diagram below, which shows the segmentation, normalization, orientation estimation, reach frequency estimation, and the GABA filter. So moving on to our methodology. For face recognition, high cascade classifier machine learning algorithm is used due to its high level of accuracy. It classifies the images by calculating the high features which are shown on the diagram here. So the pixel value, using the formula, pixel value is equal to sum of dark pixels divided by the number of dark pixels minus the sum of light pixels divided by the number of light pixels. So that is the formula that is used by the high cascade classifier machine learning algorithm. The software that is used on the study was developed using Visual Studio 2019 IDE with C# and the OpenCV libraries. And the database used to store the data is the Microsoft SQL. So the results of the system, the system was tested with 27 candidates in daylight, and there were 23 in the evening with an artificial light. So this was to cater for the face in different lighting conditions. So unregistered users all were rejected, which is a true rejection report. And then in daylight, 27 were accepted after they registered. So all the registered in daylight managed to access the system. So in artificial light, 22 out of the 23 were accepted, but only 1 failed exception. So there was a test conducted as well, finger and face swap, whereby a user was had to capture the fingerprint and a different face captured. And then in this case, all the 27 users candidates were rejected. With face manipulation, whereby a user captures the fingerprint and tries to manipulate their face to try and spoof the system, 25 were accepted truly and 2 were falsely rejected. Moving forth, so the result shows the system to be 97.71% accurate with a 0% false acceptance. The 100% true acceptance, 5.26 false rejection, and 94.74 true acceptance rate. So the 0% false acceptance rate just guarantees that the system will never grant access to unauthorized people. So the conclusion, so the multimodal biometrics secured ATM, it proved that we can actually transact in ATMs without ATM cards and the memorized PIN or our mobile phones. So it reduces the risks of bank cards being stolen or lost, or maybe used by the identity theft, the identity thieves to withdraw from our account. So yeah, that's it. Thank you.
Thank you, Tumelo. Can you go back to the previous slide? Previous one, yeah, okay, yes. Okay, you can keep this also, no issue. So you were saying that 27 test candidates in daylight and 23 in evening, right?
Yes.
Were these 23 common in those 27 also?
Pardon?
Some of the people were common in 27 and 23, or they were different data set?
Or they were common. So there were
Common.
some who were not some who were not available in the evening.
Yes. So my first question is the data set sufficient? Is the number sufficient to prove the result? 27 and 23.
In this case, I couldn't get many candidates to test with. So I think in the future, I should get maybe more candidates to test.
So
with.
you can it's a good experiment you have conducted, and praiseworthy results also you got. But you can talk to your guide, right? Your faculty mentor, and try to increase the data set. Okay, this number is too small, and to validate the result. First thing. Second question is, when you talk about these 27 people, do they belong to the same gender, same ethnicity, same location?
Same location, different gender.
So yes. Why I'm telling you is, let's say I am from India. Imagine all these 27 people are Indians. And let's say even if the result is coming to be true, I can never be sure that if there are people from African origin or Western people, or let's say Chinese or Korean people, whether the result will be same. So that becomes one of the limitation.
Okay.
So what you can do is, you are from which country?
South Africa.
South Africa. So what you can do is, I'm sure in South Africa you may find a lot of Indians, lot of probably Britishers, right? People, there may be some Chinese people from Chinese ethnicity and origin. So when you increase your data set, try to include people from other place of origin also.
Okay.
Right? Okay. Go to the next slide, please. Okay. Here you are saying 97% accuracy, almost 98, and 0% false acceptance. So in 0% false acceptance, how did you get?
So I actually used this formula here to calculate the.
No, formula is fine. No, formula is fine. But did you call somebody who did not have account in the particular bank and ask them to go for transaction?
So no, it's the results out of all the 27 people who tested. None of them.
I'm simply asking, how do we calculate this accuracy? Let's say Tumelo is having account in certain bank. Let's say it is HSBC. You
Yes.
go there without your ATM card. It will recognize with you with your face and your PIN, right? Or OTP or whatever.
Yes.
Right. But let's say I, who do not belong to South Africa, and I do not have a bank account in HSBC, right?
Mhm.
And
Yes.
I stand in front of that camera of that ATM. So if it recognizes me as Tumelo, and by that way, if I can withdraw your money, that is where false acceptance, right?
Yes.
So in this particular case, out of those 27 or 23, were there some people who did not have account with the particular bank?
Yes. So that's what here, like unregistered users.
How many?
That's the first test. All the 27 testers. So before you
So,
are registered, you were to
hmm.
first test if you can access the system.
Okay. That's it.
Yes.
Mhm. No, but again, my suggestion is what you can do is that try to bring some people. One can register, right? But they may not have account. Or okay, fine. This is the way by which that is how you have done.
Yes.
Okay. So how did you choose that algorithm which you mentioned, SAR algorithm? Why that particular algorithm only? Why not something else?
You mean the higher cascade?
Yes.
So I compared it with the list with the LBP, and yeah, I found it to be more accurate, and even with the reviewing other papers. So
Okay. Are you a
yes,
master student or PhD student?
a master student.
Okay. I'm happy. All the best.
Cool. Thank you.
You may conclude, please. It's done. We can go to the next presentation, please. Okay, thank you. Our next presenter is Samson Obafemi, and the title of the paper is Awareness and Practice of Green Computing in Higher Education Institute. Very, very contemporary topic of green computing. I think we have Dr. Samson from Durban University of Technology. Over to you, Dr. Samson.
I think so. He is absent.
Yeah, I can also see in the list. Okay. Okay, I can see the next candidate in the list right now. So next presentation is on the topic showing the impact of data augmentation on models decision using integrated gradients. And the presenter is Ingrid Rida. I don't know whether it is a correct pronunciation. Welcome, Ingrid.
Hello, everyone. Can you hear me?
Yes. Good afternoon. Please
Good
go ahead.
afternoon.
Here it is good afternoon. I don't know what exactly is the time at your place.
Also, okay, let me share my screen.
Madam, you are from which institute and which country?
I'm from Croatia.
Croatia.
Croatia, yes.
Okay.
Okay, do you see my presentation?
Yes, I can. Please go ahead. Welcome.
Okay, hello everyone again. My name is Ingrid Hrga. I'm a PhD student at the University of Rijeka in Croatia, and I will present the results of our research conducted with my supervisor, Marina Ivašić-Kos, on the impact of data augmentation on model decisions, in which we used integrated gradients as a method for genetic explanation. The content of the presentation is as follows. First, in the introductory part, I will explain
the motivation and goals of the research, and then we'll briefly review some of the most commonly used methods for explaining convolutional neural networks. I will then move on to the methods used in our research and experimental setup, and then I will summarize the results of network generalization, attribution, and clustering of generated explanations. And finally, I will conclude and propose some guidelines for future research. Today's systems based on deep neural networks are becoming ubiquitous and often performing tasks that can significantly impact various aspects of human life, such as medical diagnosis or financial risk assessment. And therefore, it is important to understand the decision-making process in order to determine whether those decisions may have been biased. One of the main drawbacks of deep models is the lack of transparency and interpretability, especially since the performance and standard metrics such as accuracy for a classification task cannot compensate for insufficient understanding of inner workings. Difficulties with deep models arise from their architectural sophistication, with processing units arranged in a very large number of layers. But in recent years, a new subfield called explainable artificial intelligence has emerged with the goal to provide a theoretical basis and tools in order to make the entire process of building a model, learning representations, and of decision-making transparent and understandable to humans, especially to the end users. Among the many factors that can influence a model's decision is that of a data augmentation strategy. Data augmentation has become an often indispensable approach to increase the dataset in order to improve the generalization ability of the network. In our previous work, we investigated the differences in classification results from various image augmentation techniques applied when training convolutional neural networks. However, better results on a standard metric do not necessarily mean that the model takes into account the right parts of the image when making the decision. And for this very reason, in this work, we took a step further by analyzing how the augmentation techniques applied to training images affect where the network looks when making a classification decision. We first investigated the generalization ability of networks trained on augmented images. Then we used integrated gradients to calculate the attribution model's output to its input features. And finally, produced the explanation were clustered to determine the strategy the model uses to decide on the label and to cover possible decision-making strategy changes due to application of a particular augmentation technique. From the various XAI methods, the most popular choices for explaining convolutional neural networks are the so-called post-hoc methods, which are applied to an already trained model to discover relationships that the model has learned between the input features and the output. Among them, the attribution methods are particularly aimed at discovering the contribution of individual input features to the model's decisions. To eliminate the shortcomings of simple perturbation or gradient-based methods, a group of authors suggested that explanations should be based on a comparison with the baseline. For example, DeepLift calculates the contribution of scores of each neuron in terms of a difference for reference activation, where a reference represents a neural input chosen for a particular problem and by taking into account domain knowledge. Another method is layer-wise relevance propagation, which decomposes the output of a layer feed-forward net model into a sum of relevance scores, quantifying the contribution of every input to final prediction. However, it was shown that most attribution methods violate at least one of the key desirable criteria, such as sensitivity and implementation invariance. For instance, gradients don't satisfy sensitivity axiom, while DeepLift and LRP don't satisfy the implementation invariance axioms. Integrated gradients were proposed as an attribution method to overcome such shortcomings. The method explains the model's decisions on a specific input by computing and aggregating the gradients along a straight path from the input to the baseline, which should be an informationless input, for example, a fully black image. Another benefit is that the model provides more fine-grained explanations that do not favor positive scores like some other attribution methods. To be consistent with our previous research on data augmentation, we used the same dataset augmentations and classification models. The models were based on the pre-trained MobileNet version 3 small convolutional neural network, which was fine-tuned on CelebA Dataset or used as a feature extractor. CelebA Dataset consists of more than 200,000 images of human faces, and every image is annotated with 40 attributes. Of these, 2 attributes were selected for 2 different binary classification tasks. For the first task, easier task, we choose mouth slightly open as an example of objective one, because the mouth can be directly associated with a particular part of the image. And for the second task, the attribute attractive was chosen as an example of a highly subjective, because attractiveness is often sum of various characteristics and can hardly be attributed to just one part of the image, thus making this task much more challenging. The models were trained on a subset of 1,000, 10,000, and 50,000 training images with 5 different augmentation techniques and also without augmentation. And from the test images, we randomly selected 1,000 to use in our further experiments. So the following augmentation, we selected simple affine transformations, then more aggressive affine transformations with fill color for the background when needed, then information dropping technique, where every image was masked with rectangles, whose number, position, size was randomly chosen. Then, as a representative of image mixing technique, mix-up was chosen, which creates a new image based on 2 randomly selected images of different classes, and then performs linear interpolation of both images and their labels. And finally, augment was selected as a method that searches for the best augmentation policy by using a grid search strategy. These are settings. In order to evaluate the generalization ability of models trained using certain augmentation technique, we tested them both on non-augmented and also on augmented images. And then we generated explanations in the form of integrated gradients. For integration method, we used 50 approximation steps, and as a baseline, we chose a black image obtained by multiplying the input with 0. In our experiment, we used PyTorch and Captain library. And for each combination of the target attribute, training method, dataset size, and augmentation technique, we clustered images showing the explanations of the obtained by integrated gradients. And as a clustering algorithm, we chose k-means with 8 clusters. Sorry. And now to the results. The classification results expressed in terms of F1 scores showed that generally higher scores were achieved with the mouth slightly open as a target class than in the case when using attractive as a target class. In both cases, best scores were achieved on the largest training set with 50,000 training examples and with fine-tuning. This was as expected. But when standardizing, for example, F1 scores, generally more variability between augmentation techniques can be observed in the case of attractive as a target class. And here are results of model generalization for models trained with attractive as a target class and fine-tuned on 1,000 of images. And those models showed the greatest drop in accuracy when tested on augmented images instead of images without any augmentation applied. Almost all models achieve better results on non-augmented images. But in general, larger differences can be observed between fine-tuned models trained on smaller sets, especially when using mix-up as augmentation. But as a number of training examples increases, the results become more uniform. On average, models with mouth slightly open as a target attribute and augmented with an information dropping technique, marked here as cut, showed the most consistent results on all tested augmentations. At the same time, the largest difference was recorded for models trained with non-augmented images. And similar behavior was observed in the case of attractive as a target attribute, where on average, the smallest difference was observed for models trained with rand augmentation. Here is an example of explanations produced with the integrated gradients. It can be seen that there is a noticeable difference in attribution depending on the applied method of image augmentation during training. The difference is not only in the strength showed as color intensity, but also in the image areas that the model takes into account for making decisions. For example, some models put more emphasis on the face, while others put more emphasis on the background. And the model trained on only slightly augmented images showed the greatest indecision in assigning importance to particular image areas. Those models generally achieved the worst classification results. And here are the 8 clusters for models trained with small slotty open as the target attribute and fine-tuned on 10,000 images. And for this combination, the classification results were fairly uniform, but here can be seen that the difference exists concerning which aspects of the inputs were most relevant for making a prediction. In the case of non-augmented images on the left, the focus is on the whole face with considerable importance given to the background. In the case of more aggressive affine transformation on the right, the model is more focused on the lower parts of the face where the mouth is located and with significantly less reliance on the background. But this difference cannot be observed from the classification results alone. In contrast, the classification results for models with attractive as a target attribute and fine-tuned on 1,000 training examples indicate clear difference between individual augmentation techniques. But here, if you look at the distribution, this difference is not so obvious. Here, the focus is mainly on cheeks, foreheads, nose, lower part of the chin, with different levels of attention focused on the background. Since it is more difficult to estimate which part of the image should be given more importance with attractive as the attribute, we calculated the similarity score between the attractive and all other attributes. And it turned out that the mentioned parts can be related to the top 10. And to conclude, in this work, we analyzed the influence of selected image augmentations on the model explanations. We first investigated the generalization ability of individual models by testing them on augmented images, and the results showed that more complex augmentation techniques applied to train images yielded more robust models. We then generated model explanations using integrated gradients and clustered them to uncover various attribution strategies that the model used to classify images. And the results showed that even when the accuracy is fairly uniform among models, there can be a significant difference in which parts of the image were the key to a particular decision. And such difference may be due to the chosen augmentation technique. And in our future work, we intend to expand this research to object detection models and more complex images showing more diverse scenes. And thank you. Sorry, I cannot hear you.
Okay. Thank you. It's a good work. Wonderful algorithm you applied and very effective presentation you made. I would like to ask the same question which I posed to Melo. In your data set, whether you had people from different ethnicity, gender, age group?
This was a publicly available data set, so I don't know the exact. So there was genders. In just a moment. Classification
of the data set.
Here are some images from this data set. So those are images of celebrities. There are 40 attributes, and also gender is one of the attributes. I'm not sure how on the gender representation, but for ethnicity, this is not recorded.
So one just question is, whatever the result you got, which you presented here, what will be the application of your results? Who can use this? For what purpose?
Yes, because usually data augmentation is it's not paid much attention to data augmentation. Usually it's not considered very important. It's something that is used or reused with the same settings from another paper maybe. But we wanted to show that there can be really important difference also not only in classification results, but also in the parts that are taken into account when making decision. For example, face recognition systems are very problematic, and if data augmentation can also contribute to some wrong and biased decisions.
True.
So
True.
this can contribute to the bias.
So what will be the other application of this research which you intend to pursue in future? What more?
Yeah, topic of my dissertation is image captioning. So gradually, I want to discover the best approach to augment images, not only for classification, object detection, but also for image captioning, where it's needed to combine both images and the text.
Okay.
So
Great.
it should be a gradual.
Yeah. All the best for your PhD work, and I think we learned a lot. Thank you very much.
Thank you.
So now we move to our, I think, last presentation, which is scheduled. The topic is computer security, importance and scope in organization. Jos Antonio. Is Dr. Jos here? Miss Richa?
Sir, actually, he is also absent.
So are we done? Or still somebody has
Actually, we
joined?
have a one presenter. It's a Samson is here, but
I saw him, but now he is not here.
yes, he is not here. So we can wait for a 5 minute.
No
Maybe
issue.
he can rejoin again.
No issue. No issue. So let me repeat the names of the people who could not make it. I think Elena already presented. Anybody, the Prashant Vats? I can't see him here, but whether he has logged in through somebody else's account. Prashant Vats? No. Tumelo has already presented. Samson, he was here for some time back. What about Jos Antonio? Is he here?
No, sir, he is not here.
Not here.
So we can wait only 2 to 3 minutes. Otherwise, we can close this session.
Okay, Richa, no issue.
Okay, sir.
Richa, should we conclude?
Yes, sir.
Okay. So, friends, originally there were 6 papers scheduled in this session, which was part of the 6th World Conference on Smart Trends in Systems, Security and Sustainability, 3S, right? But out of 6, there were only 3 presentations scheduled. But one good thing which I can see in the papers which are present, the theme chosen is wonderful: smart trends in systems, security and sustainability. And in our track itself, there were paper related to security, which was presented by Tumelo, right? Advanced trends, which were presented by the other 2 colleagues, Elena and Ingrid, related to data augmentation and intelligent electronic devices. While there were presentations related to sustainability also, like green computing, of course, which could not be presented. So it was nicely balanced session. However, we were devoid of some learning which could take place if all the 6 presentations were there. Personally speaking, I learned from the 3 presentations took place, and I'm sure that may be the case with the other colleagues too, right? We wish that we could have other presentations, but probably they were occupied and so. And I can see throughout the session, there were at least 4 to 5 people, right, who did not have paper presentation in this thing, but they were here as an audience. So I'm sure they also must have learned a lot. And thank you very much, GR Foundation and the organizers, for inviting me. And there was a useful learning, and all the best to all the presenters for their personal and professional life. Thank you.
And thank you so much, sir, for your valuable time and for your valuable presence, sir. Thank you so much for being a part of this conference. I would like to ask my team to share a certificate.
Thank you.
and all the presenter would be getting digital certificate by email within 2 to 3 working days. All the papers have already forwarded to the Springer, so kindly be cooperate with the team of WS4. Actually publication will be live 5 to 6 months, so please cooperate with the team of WS4. And there's another request. Kindly please turn on the camera for taking a quick snapshot. For making this virtual conference more memorable. Thank you so much, everyone. Thank you so much, sir.
Thank you, Richa. Best wishes.
Thank you, sir.
So with your permission, can we conclude and leave?
Yes, sir. Yes, sir. Sure, sir.
Thank you. Thank you. Bye.
Okay, sir.